IoT. Who's built or experimented with IoT applications in the audience? Okay, does anybody work for a company that delivers IoT products? Okay, a minority of people. So for those of you that don't work in commercializing IoT, I just want to spend a couple of minutes talking about why IoT is a big deal, why there is so much opportunity and adoption of connected device products today. And then we'll go and talk a little bit about building apps of this type. So there's a triad, okay, which is driving really widespread creation of IoT applications today, a triad of different factors. Those things really are these. So the first thing is the cost of microcontrollers, okay? So connected devices, obviously what we're talking about is very large volumes in a lot of cases of intelligent devices that are out in the field on networks talking to some central infrastructure. The cost of delivering those microcontrollers, the things that puts the intelligence out in the devices, is falling very fast, okay? And it's falling in two ways. First of all, as mobile CPUs get more powerful, there are a lot of fabs out there, semiconductor fabs out there, that are still manufacturing chips, essentially at sunk cost prices. So you've got a fab that's making low power ARM CPUs or other low power microcontrollers. They no longer have usage in handsets because the handset manufacturers have moved on to CPU technology that's a lot more powerful. So you've got excess capacity in the supply chain. You've also got the rise of SoC, system on a chip. Okay, and what system on a chip is, it's fabbing the Wi-Fi controller, the memory controller, solid state storage, and the CPU all on one die. So you have a very low cost component build to provide all of the functionality that you need to build a connected device. So that's one thing. The second thing is in network connectivity. There's a couple of different areas here. So is anybody here familiar with protocols, technology like LoRaNet? Okay, so again, a minority of people. It's a low power radio network infrastructure. You have one base station, and that one base station has a line of sight radius of about 15 kilometers and can support about 25,000 devices. The base stations cost about $250. So it's a very cost effective mechanism for connecting a city full of things to some back-end infrastructure that you want to run. There's actually an open source free LoRaWAN network called the Things Network that anybody can join and set up a radio base station on and then provide connectivity free of charge to a community of builders in their area. So if you want to check out the Things Network, that's an interesting way to get started with low power WAN technology. The other thing that's relevant here, of course, is who's got a mobile phone here? Okay. And who is still on 3G or 2.5G only and doesn't have a 4G service? You do? No. So nobody in this audience. You're the pioneers, right? So you're on the front edge. But actually, there are a tiny minority of people that still have 3G phones, believe it or not. There's almost nobody that will default to a 2.5G network. But the 2.5G networks are still there. So what happens to the carriers that are running those 2.5G cellular networks? They want to generate some return off that sunk infrastructure, don't they? So you've got people like Vodafone, Telefonica and others. They'll sell you a worldwide M2M plan that allows you to connect devices globally with one standard SIM that you use. You put those into your automobile, into your industrial welding device, into your oil rig, and you can connect these devices to a data network at extremely low cost because the carriers already have the networks and they're not being used. Okay, so that's two things that are driving creation of IoT applications. The third thing, of course, is the cloud. I would say that, wouldn't I? But it is just much easier to experiment and build the back-end infrastructure that I've talked about quite a few times already using the cloud than it is using traditional infrastructure approaches. You can experiment a lot more easily. You can scale your applications a lot more easily. You can deploy them globally, very, very simply into multiple regions around the world. And you can also benefit from the security and authorization layer that is built into these services to build highly secure IoT applications for regulated and privacy-sensitive markets. So there's really these three factors that are driving widespread adoption of IoT today. It's easier today to create IoT products because of these factors than it ever has been, but by a long margin, by a broad margin. Okay, so if you're interested in IoT, it's a great time to build. Who here got into software development because they thought it was fun? Did anybody not get into software development because they thought it was fun? Okay, that's a better way to ask the question. Okay. Now, there's a joke here, of course, which is, you know it's my birthday today? Some people do. It's my birthday today. And I'm entering into the people in the second half of their career today. I got 20 years in technology on the 6th of October, okay? Bob's laughing at me. Only 20. Okay. Probably the only guy in the room that could be older than me. So that's a long time ago that I started, but when I started in tech, I got into it because I enjoyed software development. I thought it was an interesting intellectual challenge, kind of good workout for the brain, a healthy combination of logic and maths and building stuff, right? It's kind of fun to do. And there's another joke here, which is, if you play the life of an older IT professional backwards, it's about a guy who gets happier and happier as he learns less and less about computers. Squeak. Okay, so we got into development because it was fun. But of course, there's a lot of stuff that's probably hard and probably a lot less fun about actually running applications, okay? So building them is great. There's nothing really more satisfying for me still today than seeing the positive reaction that customers have when we ship a new feature or a new service that helps make things simpler and easier for them. It's a great part of development. It doesn't matter whether you're working on a cloud service platform like AWS or you're building specific single-purpose mobile apps. It's still a nice feeling when you put new functionality into the hands of customers and you get some positive metrics back that indicate that they like it, right? That's the really fun part of the role. Unfortunately, there's some stuff that's just not that much fun, some stuff that, if it goes wrong, can cause you to have hair like mine, white in color and receding. Okay, so deployment, operating apps, scaling, and then we get into really things that really are not fun. Okay, so security and compliance, cost optimization, lifecycle management, retirement. These are all things that are. Does anybody think these are fun? Few. Oh, one person. The majority of you are with me. That's good. Okay, so some stuff about apps that isn't fun. Of course, serverless it helps solve a lot of these issues because you are moving away from the operational aspects of running the platform. You can spend a lot more time focusing on features and focusing on the code that implements those features. So it's a way to increase the fun quotient in your daily life, in my view. That's my hypothesis anyway. So of course, one implementation of that is Lambda, which you're probably going to hear a lot more about during the day. So I'm not really going to spend a lot of time on that. What I want to talk about is how you apply broader serverless techniques to IoT. And in doing that, what I'm going to do is talk through an IoT platform that AWS has created in a little while and illustrate how it can offload some of the application class specific challenges that you face when you're building these kinds of apps. So if we're going to talk about offloading application class specific challenges to the platform, we probably ought to spend a little bit of time talking about what those class specific challenges are. What are the things that are particularly difficult still in building high scale, secure, rapidly evolving IoT applications? So here are some things that you need to deal with, okay? First is device connectivity, okay? So we know radio networks are not infallible, okay? They're affected by a lot of things. And we also know that one of the key characteristics for many IoT applications is power and CPU footprint. You want to minimize power consumption by using the smallest CPU that you can, the smallest powered radio transmitter that you can, so that your device has a long life out in the field. And it can quite literally be in the field. We've got a couple of interesting customers at AWS that are doing this. One called Ice Robotics here in the UK. They connect cows to the internet. They have wearables for agricultural livestock, essentially. They put collars around the necks of these animals. The collars have two things in them: a microcontroller with a radio, a low power line of sight radio actually, and they have an RFID tag in them, and a temperature sensor. So they're detecting when the animals are getting hot. Being hot is an indicator that your animal might be getting sick. Sick animals deliver less milk. So they have them on dairy farms, essentially. And then once they detect an animal that's got abnormal heat, abnormal body temperature, they send out a vet with an RFID scanner, can walk around in the herd. It will proximity alert when he gets close to the animal that's affected, that's reported. He can find it by the ear tag, of course, which they have, which helps him identify that specific animal. And then he can treat it with preemptive antibiotics. Get the temperature down, the animal becomes more productive. That's the business model for the service. We've got another customer, quite similar in the Nordic region, a guy who used to be the chief architect there, used to do a great talk. He'd draw a picture of a cloud, and then he would say, you guys all think this is a cloud, but it's actually a sheep. And he'd like draw 4 legs and an eye and a mouth on the cloud. It's very funny. They connect sheep to the internet, same reason. So it's yield for wool in their case and yield for lamb. So they're trying to maintain the herd. Same challenges, low power radio, sealed, it's waterproof. You don't want to tamper with it. You might break the waterproof nature of the device. You might actually increase maintenance if you do things like replace the batteries. So they basically use the units and then discard them. But the radios are very low power. This means that when a sheep goes down into a valley or into a wooded area, the animal's no longer connected to the radio network. So you can't read state from it. So how do you do that? That's a challenge. Authentication and authorization. So IoT today extends well into regulated and safety critical sectors. We've got a customer, Philips Healthcare. They connect medical imaging devices to AWS. They stream medical data, which is used to form X-ray images, which can be viewed on mobilized apps, stream CAT scan and MRI data off their devices. They store this data in AWS and they make it available to customers through a set of mobile apps that clinicians can use to view and share medical imaging data. What do you know about medical imaging data? It forms part of the EPR, the electronic patient record, so it's regulated. In the US, there's a standard called HIPAA that applies for this. You have to ensure that the data is intact, okay, that it's not being tampered with. And of course, once it's in the cloud, you have to ensure that only those that are authorized to view it can do so, and that every access is audited. Okay, so you've got things like that you need to build. And in safety critical, how about remotely controlling 30-ton pieces of farm machinery from the cloud? Okay, so we're going to have our John Deere planter. We're driving it across a huge open agricultural area in North America. We want to use telemetry data to determine how deep the seeds are planted. And also we want to tune a fertilizer load for each planting operation based on the soil conditions in that particular part of the field. It's another real use case. Now the telemetry data stream is not safety critical, but the fact that the machine is moving, it's very heavy, that is safety critical. So we want to make sure that only authorized controllers are allowed to send telemetry control data down to that machine and make it stop, start or turn, right? So we've got crypto that we need to embed in the service to make sure that we've got mutual authentication. We know who's at both ends of the link. We know that whatever's been sent across the link is not being tampered with. And we know that an appropriate policy can be applied to messages that are going to and from the device, so we can have a principle of least privilege in our IoT app. Again, something that you've got to think about if you're building these kind of applications. Device registration. So this is first use. You know, I've got my Raspberry Pi over there, which I was going to demo to you, but the Wi-Fi in here is terrible, so I can't. It's simple, all right? I connect that to my machine with a USB cable. I see a file system. I can flash keys and certificates onto it. Super simple, okay? Let's say I'm manufacturing 50,000 of these. This is an AWS IoT button. Inside it is a system on a chip, a battery, and that's about it, a little bit of embedded C. How do I get my keys and cryptographic certificates onto that when it's been made in the Far East by some semiconductor integrator and manufacturer, and I can't get into the manufacturing facility, never mind get to the device? So what do you think? I need an X509 cert and a public-private key pair, which is unique to each device, on the device, and registered with some identity back in the cloud. How do I do that? It's quite a difficult problem to solve. And this goes to this as well, so cryptographic and security materials handling. I just mentioned X509 certs and public-private key pairs that need to be uniquely loaded onto each device that I'm going to be using. If anybody gets the certificate, they can spoof my identity. If anybody gets the public and private key pair, they can intercept data coming to and from my devices, and they can man-in-the-middle attack me. So we've got to treat these materials carefully, right? Again, it's another challenge that you've got to think about solving. And then we're getting into the back end. We're now back in the cloud. We've got all the usual software lifecycle, scaling, and maintenance issues that affect the application logic that we're going to use to actually build our app, because we've got the connected devices, but it's about what you do with the messages and data that comes off those, right? That's where the richness of the application comes from. So we've also got to consider that. And we might also want to persist that device data. We're probably going to accumulate a lot of data over time if we've got a large device fleet. Back to my medical imaging example, they've got about 16 petabytes of imaging data right now, and they're accumulating about 1 petabyte a month. That's 16 million gigabytes of data in their storage, and another million gigabytes added to that each month. Now, that's a kind of user-driven application where they're visualizing data, but you might also have real-time considerations in IoT applications. Maybe I want to generate alerts. I heard a customer this week that I was talking to, actually. This is a really unusual use case. They've got rodent control devices. So they're mouse and rat traps that they put around buildings. They want to connect them to the internet. And they want to do it because the cost of servicing extermination equipment is actually a high component of the overall cost structure. You've got to send people out to remove bodies and put more poison into these things, okay? And the way you do that right now is you've got a truck that goes out every week, or every couple of days, and it checks. How inefficient is that? Wouldn't it be better if the devices could just tell me I've killed a rat? or I don't have any poison left. And then you could target your field force on that. That is an event-driven model where we want to know when something happens, and at the same time we might want deeper data about the state of our overall device fleet. So you might have multiple layers in your analytics architecture to let you do things at different speed. It's another kind of Lambda architecture with batch and speed analytics layers that you want to create. So you've got to do that as well. Oh, and if you're very advanced, you might get into predictive, This can be hard. When am I next going to kill a rat? That could be a difficult question to answer. But if you're GE, for example, and you're connecting aero engines to an analytics platform, there's a huge amount of value in this. You can observe and learn about potential failure patterns for high-cost equipment that's very expensive to maintain and repair. And if you can tackle that and solve that challenge with predictive failure analysis, you can save a lot of money. In fact, there are whole business models around this. Earlier this year, an organization called Semiotic Labs won $100,000 in AWS credits at an event we ran in Berlin called the Berlin AWS Summit. And they only do this. They receive data from a lot of different sources, and their business is maintaining an analytical model that will give you predictive failure information for electrical motors. Okay, so it's used extensively in the rail industry. It's used extensively in brewing, actually. So they're trying to detect when industrial and transport infrastructure is likely to fail. Their whole business model is only this component of the overall architecture, just the predictive analytics. Okay, so that's all about problems, isn't it? Okay, so building on platforms can obviously help solve a lot of these challenges. And I want to talk in a little bit of detail about the platform that we provide, AWS provides, to solve for this kind of use case. Now, for me, this is actually a very good example of a highly evolved serverless architecture. It's not just about providing an execution environment for custom code for the compute part of your application. It's about a fully developed platform that allows you to create an entire class of applications without having to operate any server infrastructure. So we start at the front end with device SDKs, and these are intended for prototyping and also for manufacturing quality code that you can deploy onto whatever your connected device fleet is. We have 5 different SDKs: C, JavaScript, Java, Python, and a special purpose SDK for the Arduino Yun. So you can build and prototype connected device applications using this software. You can also use any open source MQTT client. Okay, so MQTT is a transport protocol used in low power environments to provide pub/sub infrastructure for connected device applications. The most popular open source implementation is something called MQTT Paho, which is part of the Eclipse suite of projects. But we build on top of that to provide special purpose functionality within our SDK that I'll talk about in a second. So you can use that at the front end. Then we have our authentication and authorization layer, and that's supported in communication with this device gateway. Now, the device gateway allows you to send and receive MQTT messages at any volume. We charge $5 for every million messages that you put through the gateway. So it's a managed service with elastic characteristics. It's deployed on a regional basis, and you'll get a per account endpoint when you first set up AWS IoT, a DNS name that you communicate and send your messages to. Okay? This is where we have our public-private key pair and our certificates, which obviously match up with public-private key pairs and certificates that exist on each device. We support mutual TLS auth. We also support ECC, elliptical curve cryptography, which can further reduce the amount of power that you need to consume on the device in order to operate the cryptographic operations to authenticate and encrypt your data. Okay, so that's the front end. Then when you get back into the platform, there's a little bit more magic here. A device registry that allows you to store metadata associated with each of your devices. It could be serial numbers, firmware version builds, or the physical attributes of your devices. It's a document database that you can query in order to filter and select groups of devices that you might want to operate on. So give me a list of all the devices that are on firmware 1.06, and you'll store your state in there. You could then operate on those devices to push a firmware update, for example. Okay. Rules, we'll talk about this a bit more in a second, and these device shadows. This is a cool feature. This gives you an asynchronous representation of the device in the cloud, where you can call a sync operation from your SDK periodically and push an up-to-date representation of your device state into this shadow. You can then read the shadow asynchronously via another web services API. This solves for our connected cow and our connected sheep. Okay? They can push their data every 45 minutes, every hour, we can have an async process which comes along and reads the device state every 45 minutes or every hour, but those windows do not need to be lined up. If they update at 5 past the hour and we update at 5:02, we'll just be able to read and write state. We can get the last reported state out of the shadow, and if we update state, that will go into the shadow at the next synchronization opportunity. So it really simplifies the process for building in intermittent connectivity or low power environments. This is a web services API which you address using either our CLI or our SDK tools. Super simple to do. And then on the rules, this is where the link to Lambda and other AWS service is established. So what we're sending off our devices are JSON messages, okay? So JSON structures that contain data about our devices, and actually these are also JSON structures that maintain state. When we receive a message, we can evaluate the contents of that message, read its attributes, and we can operate on that message. So a simple example would be thermostatic control. We're getting messages that are reporting temperature. We only want to operate on messages that are either above a certain threshold or below a certain threshold. So we establish a rule with our rules engine that says if temperature is greater than 50, do something. If it's less than 10, do something else. One of those things could be a Lambda function. Another one could be a Kinesis stream. Another one could be persisting the messages in Amazon S3. Another one could be sending them to Redshift for long-term analysis. You can have as many of these rules as you want. They can all operate in parallel on the same message stream. A very powerful feature for building completely serverless, completely executionless IoT applications. I receive a message and I want to do something with it. Well, one of the things I can do is republish it back out to another device. So my thermostat and heater example could be implemented completely without AWS Lambda, and actually without any of the charges other than the $5 per 1 million messages that go through the gateway. It's, I'd say, an evolved platform for building applications where you only need to configure logic. You don't actually need to run anything. Now, if you do want to get into interfacing with third-party APIs, any other services, you can hang Lambda on the end of here as one of these triggered services. The Lambda functions will will receive the contents of whatever JSON message comes through the gateway. So that is the schema that you have to work with, and you can build whatever you want using that, of course. So what am I saying here? It's my best slide. If you're building a product, build a product, okay? If you're building a platform, remember that your customers are people that build products, and then build a platform. Okay, so don't build a platform unless you're building a platform, in which case, fine, build a platform. Make sense? Good, okay. Smart people in the room, you got it, cool. So, building Hello World for developers. This is an important aspect of platforms, isn't it? It's accessibility. Whenever we start with a new programming language or a new framework, what do we have? We have Hello World for Lambda. It's in our console. You can set it up. So we tried to do this at AWS in order to stimulate developers to work with the AWS IoT service. And we built this, actually, the first time around, which is a slightly different logoed version of that. It's an AWS reInvent button. And we gave these away at reInvent last year to, actually, a lot of developers. When I press that for the first time and hold it down, I configure that device to connect to a Wi-Fi access point. So it's got a system on a chip inside it with a Wi-Fi radio on it. Okay? And then the next time I press it, it will send a JSON message to the AWS IoT endpoint that's configured within my account. There's a little bit of setup that I do on the device to enable that, specifying my account details. But basically, each time I press that, I'm getting a 3-attribute JSON object containing whether I've pressed the button once, twice, or held it down, the current battery of the device, and its serial number. So there's some static and some dynamic data, which is embedded in the device. That goes to our endpoint, and you can interpret it and operate upon it using the rules engine. So you can use that to trigger Lambda functions. Very, very simple. Okay. The other place you might have seen this same form factor device is here. So you know these Amazon Dash buttons? These are available in the US and in the UK now. We manufacture these with FMCG manufacturers. They're the same in terms of hardware, but rather than talking to the AWS IoT MQTT gateway endpoint, they talk to an endpoint in Amazon retail, and you can use them to buy products. Well, that's what they do. You buy products with them. When you get one, you set it up with our mobile app, configure it with your Amazon retail account, specify which particular product from the branded manufacturer you want to purchase when you press it, and that's it. You can basically reorder washing powder, you can reorder toilet tissue, you can reorder all sorts of stuff, dishwasher tablets, even Play-Doh. You know, if you're a complete masochist and you want your house to be ruined, I recommend that one. But thankfully, you can also get Vanish carpet cleaner on the same thing, and I figure if you just press both buttons together, you'll be fine, right? So, yeah. So we put this device out a year ago, and it turns out developers are quite creative. So this is some of the cool stuff that developers have built using the service, just to close up. So the first is ping pong scorekeepers. You actually have 2 of these on the table, and it prevents cheating, you know, as long as somebody's recording a video of when the button is pressed. Otherwise, you could spam the button and, you know, hack your score. But we'd never do that. Slack-powered doorbell. Lambda function, Slack credentials, very simple. It's a rudimentary one-way chatbot. You press the button, it posts a message. Go and answer the door. I didn't subscribe from that channel. To be honest, let somebody else answer the door, but there you go. Emergency Suite Green. So there's lots of examples of customers that have integrated this with third-party services for retail and product delivery and stuff like that. This is a great example of a customer who likes salad. Press your button, get a salad. So easy lunch ordering. And then this is my favorite. This is the most highly evolved. So again, another Lambda function at the back end. Nerding out. Maybe it should be deciding where to eat without thinking. It's probably a better title. So what he does, the developer did here, was he integrated with a variety of different public APIs. So Yelp, Google Directions, Lyft, the weather, the amount of money that he has in his Stripe account, and he uses those different values with a model to determine what he should do for dinner. Okay, so if the weather is good, the bank account balance is good, and the location is convenient, it'll recommend him a nearby expensive restaurant that he can walk to. If the weather is bad, the bank account balance is low, he might get this: F it, just get a delivery from Jimmy John's. The number is there. So it's simplifying the process of deciding what to eat. Now there's all kinds of stuff that you can build using this system because, as I said, it's sending messages to our gateway, and from there you can integrate with any of these other AWS services. So it's super simple, all done without any server infrastructure, of course. Now, these IoT buttons are not available in the UK right now. So what if you want to do this right now? Well, solving for that. Hardware you might need, a Raspberry Pi, okay? Lots of electronics kits available for the Pi. The Pi itself is £39, I think, here. And you can buy all of these different sensor kits. The sensor kits are cool. This one in particular, this Sunfounder, comes with a lot of examples written in C and Python that help you understand how to work with the different sensor modules that are provided. There's a lot of stuff there, from buttons you can press through to infrared beam detectors that you can use to work out whether people have walked into your office, through to temperature sensors, humidity sensors, compasses, so digital magnometers, all kinds of stuff. Okay, pretty cool. And all with examples, with worked examples as well. For optional fun, you can see this one's got this Pi Sense hat on it. This is actually a collection of sensors that were sent to the International Space Station with a project called Astro Pi, where they put the Raspberry Pi into space. And it has lots of different sensors built on the one package using the I2C bus on the Pi. And again, it comes with a Python SDK, this one, so you can manipulate the sensors. The white thing that you can see there is an 8x8 LED matrix, so you can also print messages, flash colors. I've got a demo which I can't show because there's no Wi-Fi, but it's called the Pi Disco Light. You're basically sending streams of colors to the Pi, and it lights in sequence with whatever you send to it. It's done asynchronously using our device shadow. Okay. Getting started, I'm going to share these slides, obviously. So these are the libraries and Python modules that you need to build this stuff if you want to do it. And this is the setup guide for our IoT service. If you want to build the SDK, you first of all need to build the CPU U-test library, because obviously that's an ARM, and our library's being developed for Linux, but it's perfectly compatible. As long as you have the CPU tests, it will make the necessary modifications to allow you to run our SDK, our C SDK, on the ARM CPU rather than the Intel. Everything works fine. It's very easy to get started with. And here's a couple of examples that you can get there on my GitHub. Emulating the AWS IoT button, so that's a C++ package that you can download, compile on your Pi as long as you've completed the prereqs. There's a wiring diagram in the repo, connect a push button to the Pi, and you can basically build the AWS IoT button using a Raspberry Pi with that package. And then the second one is the disco light, so controlling the Sense hat, flashing up disco light using our device shadow. That's a little bit more sophisticated, and obviously it's good for those that are interested in seeing Python samples as well. Okay, we also have other starter kits. So if you're into Arduino, so embedded C essentially, and you like their IDE, very simple programming model that they provide, we have a lot of device partners that we've worked with to validate compatibility with our SDKs. These are mostly ARM, but there are some other microcontrollers there as well. And there's around about 15 to 20 different hardware partners. You can find them all on our website. Okay, so if you're into Arduino, you can also take a look at that. And that is all I have.